Alright, welcome to a quick lecture on the von Thunen model, and we'll talk a little bit about transportation, the effects of transportation on von Thunen. I am, of course, your lecturer, Ms. Chris Gall. So, some quick assumptions that von Thunen made when he established his model, and any model is going to have assumptions to it, so you always want to look for what those are. So, assumption number one is that what we've got is a city that's in the middle of an isolated state, which means it's not impacted or influenced by anything that's going on outside it or around it. The land of this isolated state is what's called an isotropic plain, and that's really a fancy way of saying that it's flat with no internal barriers to transportation, so no mountains, no rivers, things like that. That the soil quality and the climate are consistent throughout this isolated state. Okay, so it wouldn't matter where we grew things, it's all going to come out the same. Also, remember, von Thunen created his model in 1826, so that's before modern transportation, largely. You see some trains that early, but not a ton. And so farmers in his model are transporting their own goods to market, and they're doing it using ox carts, and they're going directly to the central city right across the land. Okay, so there are few or no roads in this model, in the original. And then also what you have to note is that farmers act to maximize profits and minimize costs. Okay, so if we were talking about economics, we would call them rational actors. So these are some of the assumptions, and some of them right away you can already see are a little bit iffy. Okay, right? The idea that the city is in the middle of a completely isolated state that's not influenced by anything else that's going on around it. All right, doesn't really happen very much. That the land of the isolated state is flat with no internal barriers to transportation. Again, something that doesn't really happen. Okay, forget about soil quality and climate being consistent. That doesn't happen. So you can already tell it's kind of an idealistic model. That doesn't mean it's not useful. Doesn't mean it's not applicable. It just means that you've got to bear in mind that you're going to see some, for lack of a better term, some tweaks to it when you try and apply it to real life. Okay, it's not going to be a one-to-one correspondence. So when we talk about where do we decide to locate various types of agricultural activity, we have to look at a few different things. Number one, okay, probably arguably the most important, are climate and the natural environment. Some climates lend themselves to agriculture better than others, right? Not a whole lot of plants can grow in the desert. Why? Desert is hot, desert is dry, plants generally require water. Not a lot of plants grow in the Arctic. Again, because it's dry. I know it doesn't, that's counterintuitive given the amount of snow, but it's a dry place, it's a cold place, and plants require, in this case, heat, and they need water. They need the ability to access the water, right? And permafrost is not accessible water. Then we look at culture. In some areas of the world, you don't cultivate or eat certain types of crops or certain types of animals because it's forbidden by the culture. Okay, so it's just one of those things where they just don't do it. Okay, great example of this would be, for instance, you don't find a lot of pig farming in Muslim countries. Why? Because pigs are against Muslim food restrictions. It's just one of those things. And I could cite other examples, but that's just kind of an easy one. Then we get into some of the economic factors. And economic factors are things like land cost, they're things like transportation costs. Okay, so it's that stuff that has to do with money. Okay, and what you've got on the page here is a simplified version of the von Thunen model. Okay, again, created in 1826. If you don't already have a copy of this model in your notes, I want you to pause the video, take a few minutes, draw the model out. As with any model that I give you, you always want to be able to recognize it on site and just know that that's what you're seeing. Okay, so at the center of our model, we have what's called the urban market, the city. Okay, the cities are great. They have lots of people. Cities do not have lots of agriculture, so they need to bring in food to be able to support all the people that are living there. Nearest to the city, we have those items that are highest to transport and that require the most intensive land use. Okay, land next to the city is very expensive. So you want to make sure that you're getting a lot of product for the land that you're using. Okay, and then also things where transportation costs are high. These are things that go bad quickly. Okay, so vegetables, eggs, dairy, flowers, those kinds of things where you need to get them to the market super duper quick or you run the risk of them going bad. Okay. In the original, there was a layer of forest, but we've got a simplified and slightly modified version of the von Thunen model. So our next circle here is going to be medium transportation cost items, things that require a little more land, so it's going to be more extensive land use, but maybe don't go bad quite as quickly. And this is things like corn, soybeans, and they say mixed farming, they just mean farming where you're growing more than one type of crop. In our outermost circle, what we've got are things that cost the least amount to transport because they're just not going to go bad, and things that require the most extensive land use. Okay, so forestry, the growing of trees, right? Growing of wheat. Wheat stays good for an incredibly long length of time. I kid you not, I one time used flour that was probably 5 years old to cook with. As long as you keep the bugs out of the flour is fine. Okay? And also livestock ranching. And this one I know in today's day and age, livestock ranching seems counterintuitive for why that would be outside and not inside when we talk about transportation costs and having to do with things going bad. But remember, in 1826, you didn't kill the cow at the farm and put it on a truck. In 1826, what they did was they herded the cows to the city. And then in the butcher shops in the city, that was where the cows got killed. So it's actually very low transportation because the cows transported themselves to the market with one or two people and maybe some dogs to help herd them along. So remember, the key factors in this model, we're looking at really two things: cost of land, cost of transportation. Closer to the city makes transportation costs less, makes land costs higher. The further away you get, the more it costs to transport, but the less the land costs. And I know, again, that seems backwards given what it looks like on the model, but we talk about high transportation cost. Remember that the cost factors in how much of the product you lose while transporting. Okay, so we're going to jump forward just a little bit. We're going to talk about some of the types of agriculture some of the types of transportation that affect modern agriculture. These are things like planes, boats, trucks, and trains. Okay, planes enable us to get places very, very quickly. And when things are packaged well, you load something up on a cargo plane in South America and fly it here to Seattle. It can be here in probably a day. Okay, boats are not as quick, but with the advent of refrigeration, we can put a lot more on boats and they go a lot quicker than they used to. All right, and trains are kind of the same way. Using refrigerator cars, we can send trains all over the world. Trucks typically are used for closer to home items. Okay, kind of makes sense. But even trucks come with refrigeration, and what that means is that we can actually, what we've done is we've expanded our ability to send out goods because we've expanded the ability to keep them from going bad. And that was the key part of that high transportation cost, is how much are you going to lose because it goes bad on the way to the market. Okay. Then when we're talking about effects on of transportation on agriculture, again, modern transportation means that things stay fresher for longer due to refrigeration, and also due to our ability to package things well. Right, the 5-year-old flour that I mentioned earlier was in an airtight container, and that's what kept the bugs out. Okay. In the late 1800s, mid 1800s, we started to can things, and we started to figure out how to seal things in such a way that we were able to keep the bugs out better. The other thing to remember is that we're able to transport things much further, and we cover a much greater distance to market. So we can get things to market faster. We can transport it significantly further, and what this does is opens up much wider possibilities for where things are going to go, right? Here in Seattle, we get, bananas from Peru, or we get apples from Eastern Washington, right? So we can transport all that stuff and move it around much easier and not have to worry as much about what's going to go bad and how much are we going to lose on the way there. So when we take von Thunen and we introduce him to modernism, here's kind of my 2 cents, which is to say that generally speaking, the model doesn't really apply to the modern period. Those changes in transportation and also in the types of products available, read GMOs, make this model less relevant than it was in the late 1800s and early 1900s. Time-space compression means that goods get to market significantly faster than they were able to in that time frame when von Thunen was writing. Okay, and time-space compression, again, that idea that with increased transportation and increased communication technologies, what we've done is moved places not necessarily physically closer, but metaphorically closer, because we've made it much easier to go from one to the other, or to communicate from one to the other. With those GMOs, or even really where we're not modifying at the genetic level deliberately in a laboratory, what we're seeing is plants are now being bred to grow in different areas and also under different conditions than they might do otherwise. Okay, and what that means is that we can grow crops in areas where they didn't grow before, putting them closer to market, or in areas where maybe the land is a little bit cheaper in the lake. It's also important to note that plants and animals are plants in particular being bred to keep for longer once they've been pulled out of the ground or plucked off the tree, and also to mature more quickly, which means what we can do is we can reduce the need to get to market as quickly, and we can keep the markets replenished. And that's why I can go buy apples all year, bananas all year, the like. All of that being said, even if the model doesn't apply as much to the modern period, you still need to understand the model, you still need to know the model, you still need to recognize the model when you see it. Okay, so what we've really been talking about here is the von Thunen model for agriculture. Again, 2 major ideas with it. 1, the cost of land. 2, the cost of transportation. And then what we did with the second half of the lecture was to talk about how transportation costs in particular, how we've been able to limit those, and as a result, what we've done is essentially turn the model into something that doesn't necessarily apply quite as well as it might have at the time it was written. So if you have any questions at all about the von Thunen model, please by all means feel free to come see me and ask them, and I'd be delighted to answer whatever questions I can.